My friend Mark, who I worked with for many years at Nottingham Radio, and my radio ham friend, and his CB handle is ZX2, and his ham radio call sign is NDJ, G7 NDJ. Right. Last time he came, about a couple of months ago, he dropped off 3 of these he bought on eBay, and they are new old stock in box, and they are the Maxon SpeakEasy. Unusually, they're the 2781 version and not the 49 meg one that you would usually see. And this is the kind of thing which is handy. You're putting an aerial up, you want to make adjustments, you can talk to somebody hands free or perhaps on a cycle ride. And it says on the back, average kind of range is 1/4 of a mile, and absolute maximum range is going to be 1/2 a mile. Now, whenever anybody says maximum range on anything like this, they actually mean at sea. So don't think for a minute you're going to walk in the park and get 1/2 a mile. It doesn't work like that. It's the propagation of the water. It's one of these little things. That's what it means at sea. So these are 40 milliwatts output, and as you can see, there is a chappie holding up something or other, and there is a lady climbing up a mountain top to talk to the gentleman at the top of the mountain. So, one of these came with an instruction book, if not all of them, which I scanned, because the circuit diagram is there. Not easy to get into. I think you're supposed to have a coin, and we haven't. But what we have got is a screwdriver with rust on it. And then there we have a 9-volt battery clip, which in UK is known as a PP3. So I'll go to stock and get one. So we'll run it on the power supply when we actually get it up and running, kind of thing. Anyway, it's done a hiss. Of course, something like this you can't connect anything external to, so it's quite inconvenient. So if I get our monitor receiver out, I think these are on channel 30 if I remember right. Perhaps if I look at the... Why hasn't anything come off the print? Well, I pressed the print button and I don't know, not happened. I think it's, it might tell us what channel it's on. It's something strange, like 21 or 39 or something like that. Let's have a look. Well, it's not 20. $22. Let's try 39 because I just remember that seems to stick in my head. I've not seen one since. I don't think I've seen one since 1989. Seven also comes to mind. Let's go back down. So I've got plenty of volume on there. It's not 40. $33. Testing 1 2 3 4 5 5 4 3 2 1. And if we put it into Vox mode, 1 2 3 4 1 2 3 4. You've got sensitivity, 1, 2, 3, 4. 1, 2, 3, 4. Well, 1, 2, 3, 4. So it does work. So what we'll do is open it up. Of course, Mark would like to see it optimised, and then Mr. Chippy is going for a very short walk down the road because he won't be needing to get in the car to test this. So what we need to do is to get this belt clip off, because if I remember rightly, the screws for the back are going to be under the belt clip. There we go. I have been in one of these once before, just out of curiosity. So the front comes away. I don't think these were cheap. I think they were £49 or something like that. They were a lot of money. So let's zoom in and see what we get. So we're going to have a transmit and a receive crystal. It's got an MC3357 FM chip, which will have the squelch built into it. So we look like we've got the detector there. So we've actually got 3 crystals. So we've got, that's going to be deviation, just there. The 9.30 whatever crystal will be transmit, and I'm assuming that one's going to be receive. I can't see what it says on it. It might say on the circuit, which I did print, but it hasn't appeared on the printer. And then we're going to probably have, it's a dual conversion receiver, believe it or not, and that's probably the 10.695. Oh, it says 10.7 in this case. It's supposed to be receiving at 0.5 of microvolts, which I don't believe, but there you go. So it's quite difficult to get to anything to actually performance test it. Our test set will not read power under, let's have a look, it struggles with anything under 100 milliwatts. So I'm not going to be able to say this does so much power. All we can do is to tune it up for maximum, and you know it's going to not be 100 milliwatts. Okay, so we managed to get that out of the case. We'll just pop the screw out. So considering the limited range, you know, this is a specialist use type of thing. These are actually made considerably better than what you'd expect. We've also got the other IC. We've got another, that's an LM, looks like an LM386, is it? It is an LM386, which is a 250 watt audio amplifier. And then we've got an LM324, which is, if I remember rightly, it's a quad op amp. So that's going to be used as a speech processor, I would think, on transmit. And then we've got the MC3357. So you know, there's extensive use of quite sophisticated stuff in comparison to dreadful sets like the Chizer 1+1. don't probably have as much range as this, despite purporting to do 200 milliwatts. So what we've got to do is, that's going to be the antenna connection. We've actually got to unsolder that and put our test set there instead. So it's a lot of faff. You know, I wouldn't really do these for anybody else, but I've got one as well, and I've never looked at mine, so I'll tell you what, we'll do mine as well. He's brought 3 of these. See what we can do with this one. It's going to be time consuming to do 3, so we'll see. It's not doing it, it's hooking it up to the test gear. You know, when we get to receive, we've got to do the same with the speaker. We've got to connect it to the test equipment. You know, these kind of things are very difficult to work on. So with that, we need to connect it to the power supply. So we're going to set it to 9.8 volts. And remind ourselves that positive is that one. Set the current limit on the power supply to 250 milliamps. So we're on PTT, and we don't appear to have anything happening. Why is that? Oh, I haven't switched the power supply to output. There we go. 7 milliamps, and on transmit we've got 45 milliamps, which is about what you'd expect. So I say the first thing I'm going to have to do is to disconnect that antenna and connect it to a lead so we can get into the test set. Right, next day we're back onto this. Printed my circuit diagram off from the instruction book. Probably show that in more detail in a moment. And I've got this straight into the spectrum analyzer without any attenuator. So it's supposed to be doing 40 milliwatts. Let's put this on the picture-in-picture. Let's see if we can come out a bit on that. Probably better. So when I key up, we have 16.9 dBm. I can't read this on the test set, so we're using the spectrum analyzer. So 16.9 dBm. I'll just go back to our normal camera position. Oh, we're already in our normal camera position. So 16 dBm It's 40 milliwatts. So it's doing exactly the power it should be doing. That's fantastic. Now I normally have an attenuator plugged into this, and that's a 10 dB attenuator, and then we normally have a sniffer plugged into it, but with this being 40 milliwatts, it's well within the instrument's 1 watt maximum input rating, which I would never go anywhere near. Certainly wouldn't go more than something like 300 milliwatts. So that's the way to do it, but it isn't on frequency. This is going to be fun. I think it'd be easier to put this into the frequency counter of the test set, because the spectrum analyzer, being digital, has got latency, and it's adjust weight, adjust weight, adjust weight, and unless you have something from the 1970s which takes up 3 racks, that's how it's going to be. So we're going to do the frequency on the test set. So I'll go to internal, and we'll put that up on the display. So if we go into transmit, it's saying 2792165. So it should be 27, let's have a look, channel 33, 92125, slightly high. So I came to the conclusion that's a transmit crystal. So L3, that's going to be receive. That's going to be transmit. And it looks, is L8 adjustable? But which is L8? Here's the problem. I think we're going to draw a little diagram. Right, so looking at the circuit diagram, we've got the transmit crystal, we've got the LM324, quarter of it is used as the microphone speech processing preamplifier, quarter of it is used as Vox, and the other half of it's used in receive. So we've got a crystal, got the deviation control, because we've got the output of the LM324 being adjustable there, and then being applied to generate the frequency modulation with the varicap diode there. And then we apparently have got 2 coils before it disappears off. So I've just found behind the scenes that the first coil we've got, which is here, because you can't get to the numbers, I don't know how this relates to the circuit diagram, which you don't have a layout. So that's frequency. So I am now expecting that to be transmit and that to be transmit. So we're going to go back. I've gone a stage ahead here. Frequency is now on the frequency counter, and it's 2792125. We'll just trim that a bit closer. I'll do me, and we'll go to the spectrum analyzer. I'm hoping the deviation meter will be able to pick this up. So we'll take the camera over to deviation meter. I mean spectrum analyzer. and we'll key up and see whether this is affecting that transmit. And that is the peak, so it is, and this coil I think is the final one. Just have to change my glasses, can't quite see the spectrum analyzer on screen display. Yes, we're getting less there. 13, 14, 15, 16, 17, back. It's not as easy as having a needle. 17.24. I'm not going to do the maths. I really can't be bothered. So 40 milliwatts. If it was 18, it'd be 64 milliwatts. So read between the lines, it's now probably about 47 milliwatts, something like that. So that is tuned up. It was certainly doing what they said it would do. I'm going to look at the current consumption now, whilst I'm in transmit. It's 45 milliamps, so that's fine. Right, so that's covered the tune-up. Now what we need to do is to hope we can get the test set to be able to read that small signal on its deviation meter. As I say, I don't really think it's much use under 100 milliwatts. So we'll borrow the N adapter from the spectrum analyzer. We'll put it on the test set, and we'll plug my crocodile clips into the test set. I'll go over to this display on that, the meter. So we're in power, in low power mode. Let's see whether the needle even moves. Yes, it does. And on there it says 50 milliwatts, which is about what we've seen on the spectrum analyzer. So that's good. Well, I think if there's enough to make that read, I think we've got enough to do deviation. I'm going to have to tune it in because we don't normally use channel 31, we use channel 20. It looks like, wallow, it looks like it's seeing that. So with the microphone, oh, let's get the little oscillator onto the microphone. Wallow, wallow. I can actually get 2.2 with a wallow. So let's see whether we can adjust that deviation. Can't pick anything up. What's the sensitivity thing on this? I don't know whether this affects. It may just affect Vox. So, see if we can increase that. Let's try it at that. And do a wallow now into the mic. Wallow. That's better. So that's now, it's actually peaking at 2.6 there, but it's unlikely to cause any bother. So it's just trying 1 2 1. Got my monitor receiver still on, which is not helping. Wallow. Wallow, wallow, wallow. Right, so that's that. So TX, TX, deviation. So we're left now with those three. 1 2 3. And one of those is going to be frequency, where we're going to have to use a marker oscillator. So with the signal generator, we're going to have to connect the output to the synod meter, and we'll just have to put a crocodile clip or something onto the wire that goes to the headset speaker. So again, it's 4 of these to do. You know, these take longer than a normal radio, and of course the value of these is so low that you know, you can't really say your service is going to be 45 quid on your Maxon SpeakEasy, worth 45 quid. So it's a difficult situation. We wouldn't normally do them, but I want to do mine, and I want to do these for Mark. He's such a good friend. So, and there will be freebies for Mark. Where are we? Where are we? So I want to put on the signal generator, I want to put in this frequency. Let's go to the frequency counter, and I want 27 92125. There we go, 2792125. And as you can hear, that's coming through. We need to disable the squelch. Can you do that? Oh, that's interesting. So we have a preset squelch on this. So we don't have a squelch at all. It's preset. That's not going to make it easy to set up for best sensitivity. Not easy at all. So what we can do is put S9 on the signal generator and connect up to the speaker output to the test equipment, which we will do when we find the lead. It's going to be that blue wire there. Yep, that's the blue wire there. So what we'll probably be best doing is putting a crocodile clip lead onto that. Although I could hold that on, I can't really demonstrate and hold it on. The difficulty is, by the time I get to 4 microvolts, the squelch comes in. So it's difficult to set. So we'll go to S9, we'll put the oscilloscope on, we'll do the detector. Now, can we turn the volume down? Yep, we can get the volume to where we want it. Let's put that on the oscilloscope. Turn the bench light off. So there's our S9, like we'd normally do. I suspect the detector is this one. I can't turn it. Well, it's not going to be the others. Okay, so it's well, it sounds right, but it seems to be jammed into position. I don't know whether it's intentionally done like that. Now we're going to look at sensitivity. So I'm going to have to do this not as low as I'd like. Let's put the bench light back on because the squelch is coming in. I think that's going to be frequency. So that's better signal. That's a better signal. Go back on that. So we seem to have got that aligned. I'm not showing you the sound meter, I'm showing you the oscilloscope by mistake. So for 12 dB, I mean, it's showing 5 microvolts, which is difficult to, with the squelch coming in, I can't go down any lower. So the next thing I want to do is make sure it's on frequency, and that's going to be a laugh and a half. So we're going to have to use a marker oscillator. And it says the IF's 10.7. Okay, this is where we use this little generator. I've said it's 10.7. The service manual, the instruction thing says it's 10.7. Normally CBs are 10.695. So we've got a musical note, that high-pitched one. Look, I'm going to alter this. Hit listen. So that is 10.7. So now we know the signal generator is on frequency. I'm just going to trim that. So I've got 27.92125 on the signal generator. I'll put that up on the there. So that's our signal generator. I've turned the tone off. And this musical note is coming, it's because of the 10.7, which is the IF. So I think it's going to be this coil. Interesting, it isn't. So is it that one? It is. So that's our frequency one. Notice I've got a null. So we'll listen again carefully. Go either side. So that's our frequency. So that is another of the received one. So we'll just see if we can improve that. I'll turn this off. We've now got it on frequency. So we did the transmit with the frequency counter. We've done the receive with the marker oscillator and the signal generator. So the logic is, if we know the signal generator is doing the correct frequency, which it is 27.92125, and we know that the second signal generator is doing 10.7 as required, then the only thing that can be wrong is the third variable, which is the crystal in the radio. That's what it's about. It's a dual conversion receiver. We could also do it at 455 kHz. So we'll now go back to that synod meter, put the tone back on, because I thought that was going to be frequency, and I'd adjusted that, which I had been wrong to do. So get that as low as we dare before the squelch comes in, and just give that a twiddle. Well, I would if the squelch didn't keep coming in. Oh, come on. So that's the best cyanide. Go back to that one. And that's the best cyanide. So we know the sensitivity is as good as we're going to get. If I knew how to, I mean, if this was a play toy, we could take parts out around the MC3357 until we disabled the squelch. But I don't want to do that with it being marked, and I don't want to wreck mine either. So we'll now make a note that RX detector, if we could move it, RX frequency. So that's it covered. So we don't know what the sensitivity is. It seems right. I can't see that it's not working properly, but without disabling the squelch, we can't do a sensitivity test. It's a shame it doesn't do that. If you've got squelch override, it would have made all the difference with the user. You know, some of those handhelds, 2-channel handhelds, which are semi-toys, they've got squelch on preset and squelch off, and if this had got that, you would be able to get that extra bit of range on it for the user, but they haven't done that, so we'll put it back in the case. So it's doing more than 40 milliwatts. We think it's doing about 50 milliwatts. We've got the deviation where we think it should be, and that came up a bit, and the receive, we've got a little bit more out of it, and we know the whole thing's on frequency. So a lot of faff, but we'll put it back together. Right, so to wind up the video, I've just done the fourth one. They've taken about 45 minutes each once the equipment was set up, so probably an hour and a quarter for the first, then 45 minutes each subsequently. So this one is mine. I bought it off eBay. It's got not got a battery door, and it's had the headset faffed with, probably to go in a helmet or something. So not complete, but mine works as well. So they're all now doing about 50 milliwatts, which is even better than the 40 milliwatts they're supposed to do, and they were all off frequency, and they've all been aligned as best that we can. So I think it's all good to go. So that's 3 for Mark, 1 for me. Got them done. Spent the afternoon doing it, and the next video we'll do an on-the-air test, but it's going to be different, because what I'm going to do, I'm going to go to the Harrier base station, and I'll talk to Mr. Chippy, and he's going to go for a walk, try and get him to get to the end of the lane, and if it still works at the end of the lane, see if we can walk towards the petrol station, which would be an incredible 1.1 miles away, but it won't be like that, and I've no doubt that he will peter out before he gets to the top of the range, as indeed it says so on the information on the back of the product. So they're not made to be a long range thing, they are for specific reasons, and my thing would be aligning television aerials and things like that. Do they have television aerials these days? I don't know, not had a telly for 20 years. So there we are, that's the Maxon SpeakEasy SE27, not to be confused with the 49 meg version. Everybody in a dog sells the 49 meg version, but these are a bit more hard to come by. So we'll see how they sound, etc, etc, on the next video. So thanks for watching Maxon SpeakEasy SE27, and these were from round about 1983.